Okay. Hi, everyone. Welcome to the final exam review workshop for stats. My name is Sierra. I'll be hosting this workshop. So today we will be covering correlation coefficient, t-test, one-way chi-squared, and ANOVA. So let's get started. So while I switch to the worksheet, I'm going to start a poll we have that's just what class are you in? So if everyone could answer that.
Let's say, is that philosophy 67 or what class? PH? Excuse me.
All right, looks like everyone has answered. So everyone is in stat 95. Oh, I'm sorry, I just saw in the chat. Can you hear me? Sorry, I didn't hear you. I don't know. I think I had my computer on mute. Did you ask a question?
Yeah, I was saying, is the PH 67 philosophy 67?
It's public health 67. Yeah. Cool. Sorry about that. I have my sound on now. Okay. So yeah, so let's go ahead and get started. So the first thing we're going to work on is correlation coefficient. So does anyone know what like the syllable, I guess, for, or not syllable, but the what's the word I'm looking for here? The letter, I guess, that stands for correlation coefficient. It's just a letter. No. Okay. So it is just R. So correlation coefficient is equal to R. So does anyone know what the equation for how to calculate the correlation coefficient is? It's like a pretty long equation. And if at any point anyone has an answer, feel free to unmute or type it in the chat. I'll be looking at the chat the whole time as well. So if you have a chat, you could say it in the chat too. Okay, so no one knows off the top of their head that equation. It's pretty complicated. So it is R is equal to, so N times the sum of X times Y minus the sum of X times the sum of Y, all divided by N times the sum of X squared minus, and then in parentheses, the sum of X squared times N times, so the same thing, but with Y. So the sum of Y squared minus the sum of Y in parentheses squared. Okay, so does everyone know what this sum of X times Y means? You could just say no if you don't, and then we could go over it. Don't feel embarrassed to say no, but let me know so that way I know I need to go over it. Everyone's good?
Isn't it all the values of X times all the values of Y, and then you add those up?
So what you would do is you would multiply each one. So you'd multiply 14 times 21, 11 times 18, 9 times 11, 4 times 7, and 2 times 5. And then you add all those numbers up. Does that sort of make sense?
Yeah.
Yeah, okay. Okay. So does everyone know what the difference between the sum of X squared and the sum of X in parentheses squared?
The X squared is, you like square them individually first and then add them and then
good.
X in the middle is like you add all of them, then square the total.
Yeah. Yeah, good, perfect, thank you. So I'm just gonna write that down. So this one, the sum of x squared is equal to, so that means that you would square all the numbers first. Then add. And then just like you said, so the opposite, the sum of x squared in parentheses, you add them all, or sorry, I forgot to put the sum of. So that means you add them all, then square the one number. Okay, so is that going to be the same for y as it is x?
Yes.
Yes. Good. Okay. So okay. So then let's plug in all the numbers. We should be able to do all of that now. So let's start by doing n. So can anyone tell me what our n should be?
10.
10? Okay, good. So close. So for this one, you just want to count how many pairs there are. So yes, there are 10 total. Good. But we want to count how many pairs there are. So we would just divide 10 by 2. So it would just be 5 pairs. Good. Thank you for answering. Okay. Great. Sorry, my thing keeps switching. Okay. So then let's do the sum of x times y. I'm just going to put all the numbers on this side right here, and then we'll plug it all into the equation once we get them all. So the sum of x times y. So like I said, we do 14 times 21, 11 times 18, 9 times 11, and so on. So can anyone plug that into their calculator and tell me what they get? Did anyone get a number yet?
Kind of like, can you repeat what the question was?
Yeah, so we're just trying to solve for the sum of x times y. Okay, let's just work on it together. So 14 times 21 is what? Can anyone tell me?
294.
Good, 294. Okay, and what about 11 times 18?
198.
Good, 198. And what about 11 times 9? 'What was that?
99.
99, good, okay, and 4 times 7?
28.
28, good, and 2 times 5?
10.
10, good, okay, so now we just need to add all that up. So can anyone plug that into their calculator and tell me what they get?
$629.
Good, yeah, okay, so that just means the sum of x times y is 629. Okay, I just saw a message in the chat. So we're just going over correlation coefficient right now. This is just the first topic that we started on. So we're just plugging in all the solving for all the variables, and then we're going to plug it into the equation. Okay, great. So now we just need to do the sum of x. So can anyone tell me how you find the sum of x?
You add all the numbers of x, or all the
Good. Yeah.
numbers in the x. I was wondering, is
Yeah.
regression related to correlation? Is that like in the same module or the same?
Sorry, what was the question?
Regression, is that related to correlation?
It's a little bit different.
Right. Okay, subject. Okay.
Yeah. Okay, great. So let's just add all those up. So we just need to do 14 plus 11 plus 9 plus 4 plus 2. So can anyone plug that into the calculator?
40.
40, good. Okay. So now we need to do the sum of y. So we just do the same thing, but with y. Can anyone plug that in and tell me what they get? So we just need to add up all the numbers in the received column.
62.
Yes, good. 62. Thank you. Okay. So now we just need to move to the bottom part. So we have n already. So now we need the sum of x squared in parentheses. So like we talked about earlier, so that one would be where you square all the numbers first and then add them. So you would square 14, 11, 9, 4, and 2, and then add all those numbers up, and then that would be our number for this. Okay, so can anyone plug that in and tell me what they get?
Or 18.
418. Yes, good. Okay, so now we do the sum of x squared. So can anyone tell me how we find that?
You add all of them and then square.
Good. Yes. So that just basically means that we're squaring this number that we said right here, right? Which is this one. Is that right?
Yeah.
Yeah. Okay. Awesome. So what is 40 squared?
(2018).
What was it?
Said 2018.
It should be 1600, right?
Okay.
Yeah.
Yeah, 1600.
Yeah. Okay. Great. Thank you. 1600. Okay. So now we just do the same thing with y. So the sum of y squared. So can anyone tell me what they get when they plug that in?
$38,044.
38,044. So that one is the sum of y squared. So right, because that's 62 squared. So it'll be 3844. That's the sum of y squared, right? Because that is 62 squared.
Oh yeah, sorry.
Yeah, okay, no problem. I appreciate the participation. Okay, so let's do the sum of y squared. So does anyone have that one? If not, we could go over it together if anyone is confused. Just let me know. Okay, what is 21 squared? Can anyone tell me?
441.
441. Okay, and what's 18 squared?
324.
324. Okay, and what's 11 squared?
121.
121. Good. And what about 7?
49.
49. And 5 squared?
25.
25. Good. Okay, now what do we get when we add all of those up?
960.
960. Perfect. Good. Okay, so now we should have everything we could plug into the equation. So let's do that. So what did we say our n was?
5.
5. Good. And the sum of x times y?
629.
Good. 629. Okay, and what was the sum of x?
40.
40. Good. And the sum of y?
62.
62. Perfect. Okay. And then divided by, so we said our n was 5 already. What was the sum of x squared in parentheses?
418.
Good. And then the sum of x in parentheses squared?
16,000.
Yes, 1600. Okay. And our n was 5. So, oops. So what is the sum of y squared in parentheses?
960.
Yes, perfect. 960. And what about the sum of y in parentheses squared?
3844.
Yes, good. 3844. Thank you. Okay, so now we just need to solve. So let's just do it step by step. So we'll do everything that's in brackets. I forgot something in the original equation. So it should be the square root of this whole thing. So it'll be the square root of this. My bad, I forgot that part. Okay. So let's just do it step by step. So what is 5 times 629?
3145.
Yes, 3145, good. And then what is 40 times 62?
2480.
Good, 2480. Perfect, thank you. Okay, so then let's multiply everything. Let's do the bottom part. So this is supposed to have a minus right here. Okay, what is 5 times 418?
2090.
Good, 2090 minus 1600. Okay, and what's 5 times 960?
4800.
Good, 4800 minus 3844. Good, okay. So then what is 3145 minus 2480?
665.
Perfect, thank you. Okay, and then what is 2090 minus 1600?
490.
Good, 490. Oops, 490 times, and what's 4800 minus 3844?
956.
Perfect, 956. Okay. So 665 divided by the square root of, so what is 490 times 956?
46, 84, 40.
Yes. 4, 8, 6, 4, 4, 0. Good. Okay. And then what's the square root of that?
Actually, I got 46, 84, 40.
Oh,
So
sorry.
the 6 and the 8
you're
are
right.
switched.
You're right. Sorry. My fault. I wrote those backwards. Okay. Like that, right?
Yeah.
Okay. Okay. Awesome. So what's the square root of that?
684.43.
Good. 43. Okay. So then we just need to divide. That's the last step. So 665 divided by 684.43.
I got 0.97.
Good. 0.97. Perfect. All right. There is our answer. So does anyone have any questions on how any part of that, how we got anything, any part of that at all before we move on? Also, if you aren't comfortable asking your question in front of everyone, you could also like private message me and I'll just answer it for everyone. Just in case anyone wants to do that. Okay, I'm gonna assume no one has any questions and we're good to move on then. Okay, so what is the strength? So this one is a poll question. So let's try it. Have you guys try it on your own and then after we'll go over it. So what is the strength based on the number we got 0.97? Okay, we'll wait like 30 more seconds. It's okay to just guess if you're not sure. We will go over it. Okay, I'm gonna stop the poll now. Okay, so let's go over it. So we said that R was 0.97. So that would mean that it is strong, but let's go over why. Does anyone have a reason for why they pick strong?
Because it's linear. That's what correlation is like.
Yes, correct, good. Yes, correct. So there's actually, that is correct. There's actually also numbers that you could follow. So weak is,
Also, when it means it's close to 1, right?
yes, yeah. So the closer it is to 1 is how strong it is. So weak will be like less than 0.25. That's pretty weak, right? So then medium would be 0.05, or sorry, not 0.5. And then strong is 0.75. Okay, so let's say, for example, we calculated this and we got our R value to be 0.15. What would the strength be? Let's try it on a poll. Okay, let's try it again. So if it was 0.15, what would the strength be? Weak, medium, or strong? We'll give it like 15 more seconds. So 0.15. Okay, I'm gonna end the poll now. Okay, so if our number was 0.15, then that would be a weak correlation. Oops. Okay, does anyone have any questions on strength before we move on? No? Okay, awesome. Then let's go on to the next one. So this one's also a poll. So what is the direction? So go ahead and try it out on your own, and then we'll go over it after. All right, we'll give it about like 30 more seconds. Okay, I'm gonna go ahead and end the poll. So it looks like everyone that responded got it correct. It is positive. Can anyone explain why it's positive?
Isn't it based on the sign? So since it doesn't have like the negative sign, it's
Sure.
positive.
Yes, that is correct. So since it is a positive number, it is a positive direction. If it was negative 0.97 instead, then it would be negative. Good, correct. Okay, does anyone have any questions on direction before we move on to t-test or anything that we went over on correlation coefficient?
Wait, can you repeat what you said about the direction? Why it was positive again?
Yeah, of course. So it is positive because it is related to the sign. So since it is a positive number, it would be a positive direction. But let's say, for example, it was negative 0.97, then the direction would be negative. So it's just related to the sign.
Okay.
Yes, perfect. Thank you for asking. Okay, so then let's move on to t-test if no one has any other questions. Okay. So a researcher wants to determine if there is a positive relationship between sending and receiving text. He uses the following data. Okay, so we'll start with doing the alternative hypothesis. So that one is a poll. Let me start the poll. Okay, so go ahead and give it your best shot and then we'll go over it after. We'll give about 30 seconds to answer this one. All right, like 5 more seconds. Okay, so oops, okay, I'm gonna end it. Okay, so we have a wide variety of answers. So let's start by, can someone first define for me what an alternative hypothesis is? And just definition, not related to this question, just in general.
That it has an effect. It's like the opposite of null hypothesis. Null is like no effect, and the alternative is an effect.
Good, perfect. Yes. So the alternative says that there is an effect, there is some sort of change, something happens. And like you said, the null is the complete opposite. So there was no effect or no change or nothing happened. Okay, so knowing that, so that would mean that the answer could only be there is a relationship between sending and receiving text, and there is a positive relationship between sending and receiving text. So the correct answer is that there is a positive relationship between sending and receiving text. Can anyone tell me why that would be the correct answer?
Because the hypothesis, they're trying to determine if there is a positive relationship. It's in the question. So it's like after you do all the research, you either pick one of them, and the alternative is there's effect. So that would be the answer.
Good, yes. So the reason that it is positive, it says there is a positive relationship rather than just there is a relationship, is exactly what you said. So in the question, it says, a researcher wants to determine if there is a positive relationship. So whenever you're writing the alternative hypothesis, almost every time you can get it directly from the question. Okay. So now that we know what the alternative hypothesis is, can anyone tell me what the null hypothesis should be?
Wouldn't it be that there is not a positive relationship?
Perfect, yes. And I see you in the chat as well. There is no effect, yes. So we'll just say the exact same thing, but put a not in there. So it would just be there is not a positive relationship between sending and receiving text. Okay, does anyone have any questions on that? No? Okay, so then let's move on. So the next thing is to calculate the degrees of freedom. So can anyone tell me what equation we should be using for this? How to calculate our degrees of freedom for this specific problem?
n-1 plus n-1, or n-1 minus n. It's one of them. I got.
Yes, so since this one is a paired sample, I guess, we would want to use n-2. Since there is 2, right? Since there's 1 and 2, we want to do n-2. So we would use the n-1. Sorry, the n-1, we would just do it twice. So can anyone tell me what n is for this problem?
5.
10.
Yes, why is it
And
5?
5.
Or sorry, go ahead. Sorry, I didn't hear you.
Oh, that was the other person. I'm not sure.
Oh, okay. Okay, yes, it is 5. Can anyone tell me why it's 5 instead of 10? No? Okay.
Got.
Oh, sorry, go ahead.
Nice. I forgot. I think
Oh.
this is. You look at one of them. I don't know. I forgot though.
Yeah, no problem. So it's the same as the last one. So we just want to count how many pairs there are rather than how many total samples there are. So there's 1, 2, 3, 4, and 5. So we would use 5 instead of 10 because we're counting how many pairs rather than how many total there are. Does it matter if the n is capital N? So usually when we're doing this, capital N would mean pairs and little n would mean like total. So if we were using little n, it would be 10. If we were using capital N, it would be 5. So I guess on this last one, this should all be capital N. Not lowercase n. Yes, thank you for pointing that out though. Okay, so then let's calculate our degrees of freedom. So 5 minus 2 is what?
3.
3, good. Okay, so now we just need to find our t critical value. So I have the table here. And we said our degrees of freedom was 3. So the 3 is right here. So what would be our t critical value for this one?
What number was before? I didn't get to see it.
Oh, sorry, what? We're asking this part?
Oh yeah. Yeah, I was looking at that. You can go back to it.
Okay. Okay, does anyone know what our t-critical value should be?
Would it be the one that's aligned with 0.05?
Yes.
So it would be 2.353.
Yes, perfect. Okay. Do you mind telling us why you use 0.05?
I don't really know. The professor just always uses 0.05.
Yeah, that's okay. Okay, so let me tell you. So if the problem specifies what to use, like sometimes it says use like the 0.01 level. If it specifies, then definitely use whatever it's telling you. But if it doesn't say, then you always assume that it's saying the 0.05 level. And then can anyone explain why it's a one tail rather than a two tail? Because if you look, there's 0.05 twice, right? It's here and here. So can anyone tell me why it's one tail versus two tail?
Because we're only looking for the positive.
Perfect. Yes,
Right, we're
exactly.
only solving for the positive.
Exactly. Yes. Okay. So if it had said a researcher wants to determine if there is a relationship, it doesn't specify positive or negative. What would that be? One tail or two tail?
That would be two tail.
Good. Perfect. Okay. So does anyone have any questions on how we got that critical value? No? Okay. So then let's move on to how to calculate the t-test. So there's many equations for how to calculate a t-test, right? So this one specifically, we're going to use one that has the sample correlation coefficient in it. So does anyone have that equation possibly? If not, I could give it. I just want to see if anyone has it. No? Okay, so the equation is T is equal to R divided by the square root of 1 minus R squared divided by N minus 2. So can anyone remind me what R stands for?
I have a question. What did you mean by the correlation coefficient is 0.85? Wait, how did that relate to that equation?
How does it relate to the equation I just wrote?
Yeah.
Yeah, so sample correlation coefficient is R. So this is equal to
Oh.
R. Yeah,
Okay.
so that's what we just calculated in that last one, right? We calculated the correlation coefficient and that was equal to R.
Yeah.
So we're just kind of moving to t-test based off of that. Does that make sense?
Yeah. Thank
Okay.
you.
Yeah, no problem. Okay. So cool. So then let's just plug in everything. We should have everything. So what was R from this problem?
0.85.
Good. 0.85 divided by 1 minus 0.85 squared. And then what was N again?
5.
5. Perfect. Okay, so 5 minus 2. So let's just plug everything in then. 0.85 divided by the square root of 1 minus. So what is 0.85 squared?
.72.
Yes, 0.72. Okay. Divided by, and 5 minus 2 is 3, right? Okay, so 0.85 divided by the square root. So what is 1 minus 0.72?
0.28.
Yes, good. 0.28 divided by 3. So what is 0.28 divided by 3?
0.093.
Yes, 0.093. Okay. So what is the square root of that?
I got 0.31.
Good, 0.31, perfect, okay. And then 0.85 divided by 0.31 is what?
Is it 2.74?
2.74, yes, good. Okay, does anyone have any questions on how we got there? No, okay, so then let's go on. So now we need to make a decision. So we said our T critical was 2.353, and the number we calculated was 2.79. Okay, so based on that, let's make a decision and say what our error is. So that is going to be another poll question. So go ahead and give it your best shot, and then we'll go over it afterwards. All right, let's wait about like 15 more seconds. Okay, I'm gonna go ahead and stop the poll now. Okay, so the correct answer should be reject the null and type 1 error. So I had a couple people get that right. So can anyone explain why we reject the null?
Is it because if the obtained value is greater than the critical value, you reject it?
Yes, that is exactly correct. So anytime the value you calculate is bigger than the value you're getting from the table, you would reject the null. Good. Okay, so can anyone explain why it's type 1 error?
So when you reject, but it's actually the alternative, or
Yes.
yeah.
Yes, so anytime you reject the null, there is the possibility of a type 1 error. So this is always the rule. So anytime you reject, it's type 1. And anytime you retain, it's type 2. Or the possibility of it being type 2 error. So that's just the general rule that you can use to determine which one it should be. Okay, does anyone have any questions on that? No? Okay, so then let's fill out the statistical hypothesis. So this is what it should be. So it would be T, and then in parentheses, you put the degrees of freedom is equal to, and then you put the calculated value. comma, and then P is something to 0.05. So let's plug that in based off of what we have. So what was our degrees of freedom?
Three.
3.
3, yes, thank you both. So 3 is equal to, and what was our T calculated value?
2.353.
That's the T critical value. So we want the other one, the one that we plugged into the formula. So it should be this number right here, the 2.79. Okay, and then we need to do P is something to 0.05. So because we rejected the null, would P be less than or greater than 0.05?
Greater.
So it'd actually be the opposite. It should be less than.
So when P is a really low number, that means you reject it.
Yes.
Okay.
Yes. So anytime P is less than 0.05, you want to reject the null. And when it's greater than 0.05, you want to retain the null. Okay, great. Does anyone have any questions on that entire thing before we move on to chi-squared? Okay, so we are just at about the halfway point in material. So I'm going to share the link again for the survey and the link for the YouTube channel. Will be the recording will be posted hopefully by tonight. And then the survey link, just fill out that survey so that way I can email you the blank copy, the key, and the copy we're working on right now. And you have until 4 p.m. today to fill that out so I can send it to you. Okay, so let's move on to chi-squared. So a researcher wants to determine if there's a taste difference or 4 different coffees. The data table compares the taste preference among 100 participants for 4 different types of coffee. Okay, so let's do the alternative. So let me share that poll. Actually, never mind. I don't have a poll for that one. Okay, that is fine. Okay, so can anyone tell me what they think the alternative hypothesis should be?
Would it be that they all taste the same?
So that would be the null, right? Because the null says that there is no difference or no change or no effect, nothing happens, right? So if they all tasted the same, that would be, there would be no difference, right?
So it's that there is a difference between all different coffees?
Yes, good, perfect. Okay, so the alternative is that there will be a difference in taste preference. I'm just gonna write that just because I want to make sure we have time for everything. And then, like you said, the null is that there will be no difference. So they'll all taste the same, right? Great. Okay, so now we need to find the critical value. So what's the first thing that we do when we try to find the critical value? We have to calculate something first.
Don't you need to do the degrees, the DF?
Yes, perfect. And thank you, Emily, also in the chat. So we need to find the degrees of freedom. So does anyone know what the formula should be?
N minus 2?
So for this one, it's not paired. I mean, it probably looks like it's paired because it is like that, but it's just n minus 1, yes, which is also the same as columns minus 1. So how many columns do we have? Or how many, or n, what would n be?
Wait, so what would be the difference between the paired and the just -1 and the -2?
Yeah, so this one is not paired because it doesn't have two numbers, right? It just has A, B, C, D. That's just labeling which taste preference or which coffee has what taste preference. So if we go back to this one, it has 2 columns with numbers, right? And then this one just has A, B, C, D labeling what goes with the taste preference. So if this one had like 2 numbers, so like say it was like 17, 19, 20, 21 or something, then it would be paired. But it just has A, B, C, D, so it would just be one. There's just one set of numbers, right? Does that make sense? Does that answer your question?
Yeah, I don't want to hold you back, but what did you say about the capital N and the lowercase n?
Yeah, so usually the capital N stands for how many pairs there are. So like for this example, it would be capital N would be equal to 5. And then lowercase n is usually like how many total there are in the sample. So that would be 10 for this one.
Okay, thank you. Sorry, you can go back.
You're fine. I appreciate the questions because I'm sure if you have that question, I'm sure someone else does as well. Okay. So I saw Emily in the chat said it should be 4 minus 1, good, which is equal to 3. Okay, so now we just need to go to the table to find what it should be. So we said it would be 3, which is right here. Okay, so what should our critical value be based on this table? Can anyone tell me?
Would it be 7.815?
Good, yes, 7.815. Okay, does anyone have any questions on how we found that? No? Okay, so I'm gonna write this down. So our chi-squared critical is equal to 7.815. Okay, so then let's go on. So what is the frequency observed for all types of coffee? So, sorry, let me just write this again at the top. A, B, C, D was 25, 32, 24, and 19. Okay, so can anyone tell me what the frequency observed would be? It's kind of a trick question. Okay, so frequency observed is exactly how you see it on the table. So it'll be A, B, C, D. So it should, A was 25, B was 32, C was 24, and D was 19. So frequency observed is exactly how you see it on like the table or the data set that they give you. Okay, and then what is the expected frequency for all types of coffee? So there's an equation we can use to find that. Does anyone know what the equation would be? Okay, so it's just expected proportion divided by n. So what I mean by expected proportion would just be you adding them all up. So we just need to add up 25 plus 32 plus 24 plus 19. So it's just the total amount that you could get. So does anyone know what the total was? 25 plus 32 plus 24 plus 19?
100.
100, good, 100. And then what was our N again? Capital N.
4.
4, yes, exactly. Okay, so 100 divided by 4 would be 25. So the expected proportion for all of them is 25. So let's just write that. So A, B, C, D is 25, 25, 25, and 25.
Excuse me, I have a question.
Yeah,
So this section right here, chi, is it taught in statistics, or because I've never learned this one in class, or is it for PH?
no, it is taught in Stat 95. Maybe your professor didn't go over it, but I know quite a few of the classes did go over it. Did anyone else not go over this?
I didn't.
You didn't? What professor do you guys have? Do you have the same professor?
Sure. My professor Giovanni, I think that's, or I forgot her last name, but
Okay. Do you have the same professor as well?
I have Howard Tokunaga. I think that's how you say
we have
Oh.
different professors.
Okay. Well, I do know that a couple of the other classes did go over it. I mean, I guess it's good for you to know in case you ever have to use it, but if they didn't go over, it won't be on your exam. So
Okay, thank you.
yeah. Okay. So now we just need to calculate chi-squared itself. So the equation for that would be chi-squared is equal to the sum of, sorry, there's actually not enough room to write that. Okay, chi-squared is equal to the sum of FO, which is the frequency observed, minus FE, which is the frequency expected, squared divided by FE. So let me show you how the way that I do it first. I don't really do it exactly that way because it doesn't make as much sense to me. So the way that I do it is I write the equation out for every single one and then add it up. So I just take off the sum of. So let me show you what I mean. So we want to do chi-squared A. Sorry, that is not enough room right there. So we want to do chi-squared A is equal to, and then we want to do chi-squared B is equal to chi-squared C and chi-squared D, and then we'll just add it all up. So what is the frequency observed for A?
$25.
25, good. And the frequency expected is also 25 squared divided by 25. So we can all agree that's 0, right?
Yeah.
Okay, cool. So then let's move on to B. So what was the frequency observed for B?
32.
Good, 32. So minus 25 squared divided by 25. So what's 32 minus 25?
7.
7. Okay, 7 squared. So that should be 49 divided by 25, right?
Yeah.
Okay, and then what is 49 divided by 25?
I got 1.96.
Correct, yes, 1.96. Okay, let's move on for C. So what is the observed for C?
$24.
Good, so 24 minus 25 squared divided by 25. So that should just be 1 divided by 25, right?
Yeah.
Okay,
Would it be? Oh wait, no, never mind. It wouldn't be negative.
yes, because we're squaring it, so it'd just be positive. Okay, so what is 1 divided by 25?
0.04.
0.04. Okay, and then the last one. So for D, so what was the observed?
19.
Good, 19 minus 25 squared divided by 25. So what is 19 minus 25?
-6.
Good, so -6 squared would just be 36 divided by 25. So what's 36 divided by 25?
1.44.
Perfect, 1.44. So now we just need to add all of those up. So we're gonna add 0 plus 1.96 plus 0.04 plus 1.44. Okay, so what do you get when you add all of those up?
3.44.
Good, 3.44. So that is our chi-squared calculated. Let me highlight that. That is our chi-squared calculated. Good. So does anyone have any questions on how we calculated that? No? Okay, so then let's make our decision. So that's going to be a poll. So should we reject or retain the null? And based on that, is it a type 1 error or a type 2 error? So our chi-squared, oops. Our chi-squared critical was 7.815. So even if you guys don't go over this in class, it's the same rules as rejecting or retaining on a t-test. So you guys should be able to at least guess on that part. Okay, let's wait like 15 more seconds. Okay, we're gonna close it. So everyone that selected an answer got it correct. So it is retain the null. And a type 2 error. Oops. Okay, so can anyone tell me why it's retain the null? Emily, it is not greater than 7.15. Perfect. Yeah. So our calculated number was smaller than our critical number. So that means that we would reject, or I mean, sorry, retain. We would retain. So since we're retaining the null, that means it's always type 2 error, right? Okay. Does anyone have any questions on the decision? No? Okay. Then let's do our statistical verification. So what we need to plug in is x is equal to, so we'd want to do n is equal to some number, comma, and then we'd want to do the degrees of freedom is equal to, so our chi-squared calculated, and then we do p is something 0.05. So let's plug everything we have in. So what was n? So it's lowercase n. So what would it be? So we just want to add up all these numbers right here.
Maybe 4.
So you want to add up the total, sorry, that's, so uppercase n would be 4, yes, because that's how many there are. But for lowercase n, you want to add up 25 plus 32 plus 24 plus 19 for lowercase n.
100.
Good, yes, okay, 100. And now we need our degrees of freedom. What was our degrees of freedom? 3. Yes, thank you, Izzy. Okay. And then what was our chi-squared calculated value? So it's this number we just solved for right here. So it should be 3.44. Okay, so now we need to do P is something to 0.05. So we retain the null. So should it be greater than or less than 0.05?
Less than?
So since we're retaining, it would be P is greater than 0.05. It's always the opposite of what you think it is. That's, at least for me, it's always the opposite. I feel like it should be less than, but it's the opposite. So it'll be P is greater than 0.05. Okay, does anyone have any questions on that before we move on to ANOVAs? No? Okay. Great. So this is the last problem, so we should be able to finish it in time. So a researcher wants to determine if the orientation will affect the amount of time in seconds that an adult will take to read a passage. The following data shows the researcher's results. Okay. So we need to start by finding what is the experimental hypothesis. So what is another way to say experimental hypothesis? So the way that you normally hear it, what would it be? Yes, good. Thank you, Emily. So experimental hypothesis is the same as alternative hypothesis. Okay, great. So let's do a poll and see what you guys think the alternative hypothesis should be. I'm going to go back to this page because that's kind of where you get the information from. So go ahead and give it a guess. We'll wait about like 30 seconds for everyone to guess, and then we'll go on. Okay, we'll wait like 15 more seconds. Okay, I'm gonna end the poll now. So everyone that answered got it correctly. So orientation will cause a change in reading time. Does anyone want to explain why it's that rather than like will cause a positive change or a negative change or increase or decrease? No? Oh, sorry, Emily, because it didn't specify what kind of change. Yes, exactly. So if it had said a researcher wants to determine if the orientation will increase the amount of time and seconds it takes, then it would be increase. Yes, okay, good. So then let's do the null hypothesis. So can anyone tell me what the null hypothesis would be?
It would be that there is no change.
Good, yes, so orientation. Yes, I see your answer as well, Emily. Yes, okay, orientation will not cause a change in reading time. Good. Okay, so let's do the next one. So what is the independent variable? So that is another poll question. So go ahead and try that one out. We'll wait about 30 seconds before we move on. I'm gonna go back to here just in case you need that. Okay, let's go ahead and end that. So the dependent variable, I realized I went out of order, so I apologize if that confused anyone. So what is the dependent variable? So can anyone explain to me why it is reading time?
Because your reading time depends on the orientation, if you go or not. I forgot what the question was, but basically depends on.
Yes, you're correct. So based off of that, let's do the next poll. So what is the independent variable? We'll wait about like 15 more seconds. Okay, good. So everyone that answered it got it correct. So it is orientation. Can anyone tell me why it's orientation? So why is the independent variable orientation? Okay, so the independent variable is the one that you change or you manipulate, right? So if we go back to the problem, a researcher wants to determine if orientation will affect the amount of time it takes to read a passage. So orientation is the thing that is changing, right? So that would be the thing that they're changing or manipulating to get a reading time. So that's why orientation would be the independent variable. Does anyone have any questions on that? No? Okay, so let's move on. So we need to find the critical value now. So what's the first thing that you do when you're trying to find the critical value?
A DS.
Good, okay, so can anyone tell me how we find the degrees of freedom for this one?
Would this one be n minus 3? Because there's 3 different columns.
That is a good guess, yes, but for this one, you just want to subtract from 1. I know it's a little bit confusing because it's different than what you would expect, but this one you would just want to do n minus 1. Okay, so what would n be for this question?
Nine.
Yes, good. Okay, so equal to 9 minus 1, which is equal to 8. Good. So there's also, so that's degrees of freedom total. There's also degrees of freedom between and degrees of freedom within. So we're going to use those later on in our problem solving. So let's just solve for them now. So the degrees of freedom between is the number of rows minus 1. So how many rows do we have?
Three.
Yes, good. So 3 minus 1, which is equal to what?
2.
2, good. Okay, so that's degrees of freedom between. So now we have degrees of freedom within. So when we do that, it is n minus the number of groups there are. So what was n again? 9, yes, thank you, Emily. So 9 minus, and then how many groups are there?
Three groups?
3, yes, good. So we have 1, 2, and 3. So it'll be 3 groups. So 9 minus 3 is what? Should be 6, right? So yes, thank you, Emily. So 6 plus 2 is equal to what? 8, yes. So our degrees of freedom between plus our degrees of freedom within should equal the total degrees of freedom, which in this case it does, right? 6 plus 2 is 8, and our degrees of freedom is 8. Okay, so now we just need to find our critical value. So to find the critical value, the only one that you care about is degrees of freedom total. So let's go to our table. So I know this is a very large table. Sorry, I told you that backwards. You don't care about degrees of freedom total. You only care about degrees of freedom between and degrees of freedom within. So okay, so this top part, the top part is degrees of freedom between, like this row, and then this one or that one is degrees of freedom within. So let's find the. Yes, exactly. Calculating the degrees of freedom total is just a way to make sure that we calculated the other two correctly. Yes. Good. Okay. So our degrees of freedom between was what? So we calculated that right here. So what was our degrees of freedom between? 2. Yes. Okay. So I'm going to highlight that. So what was our degrees of freedom within? 6. Yes. Okay. So now we just need to go to where they meet, which would be right here, right? 5.1433. So that would be our critical value. So does anyone have any questions on how we calculated that? Or how we got that? No? Okay. So our F critical is equal to 5.1433. Okay, so now we need to calculate the sum of squares between. So there's a super complicated formula. So it's SS between is equal to, so the sum of x1 squared divided by n plus the sum of x2 squared divided by n plus the sum of x3 squared divided by n, and then minus the overall total squared divided by n. Okay, so that's our formula. So let's try and plug everything in. So what is the sum of x1? So let me go back. Okay. So the sum of x1. Can anyone tell me what that is? So we just need to add up 3 plus 5 plus 2.
10?
10, yes. 10 squared. And what should n be? So this one is just the number of groups there are. So how many groups do we have?
3.
3, good. Okay, so what's the sum of x squared? Or sorry, x2. So it'd just be 10 plus 13 plus 17.
Would it be 40?
Yes, 40 squared. And it would be divided by 3 again. Sorry, where are you getting the 10 from? Yeah, so you just add each one of these up. That's all we're doing. So 3 plus 5 is 8, plus 2 would be 10. And then the same thing for this one. 10 plus 13 plus 17 is equal to 40. Yes, no problem. Okay. Okay, so then the next one. So what is the sum of x3? So 24 plus 22 plus 20. Okay, that is 66 squared divided by 3. So the overall total is all of these added up. So you want to add 10 plus 40 plus 66, which would be 116 squared, and then n. So that is the same n we used right here. So that would just be 9. Okay, does anyone have any questions on how we got there? Okay, we are almost out of time, so I'm going to speed up just a little bit just so we can try to get through it all. But if anyone has any question at any point, just let me know. Okay, so 10 squared would be 100. So 100 divided by 3 should be 33.33 plus, so 40 squared should be 1600 divided by 3 would be 533.33. And someone please also be calculating this to make sure I'm not making any math errors. And then 66 squared is 4,356, and then that divided by 3 would be 1,452 minus, so 116 squared is 13,456, and then that number divided by 9 is 1,495.11. So now we just need to add up the whole left side. So when we add those up, it should be 2,018.66 minus 1,495.11. And then when we subtract those two, you should get 523.55. Okay, does anyone have any questions on how we got any of those numbers? No, okay, it is about 12:30, so I'm gonna send the links and stuff again, just in case anyone does have to leave early. I'm gonna keep going until we finish, until 11:40. At 11:40, we do have to end, so let's try and get through all of this. So let's move on. So calculate the sum of squares within. Okay, so the formula we want to use for that, so SS within. Okay, so that is equal to the sum of x squared minus, and then it's the exact same thing. So the sum of x1 squared divided by n plus the sum of x2 squared divided by n plus the sum of x3 squared divided by n. Okay, so let's try and solve for that. So the sum of x squared. So that means we want to do 10 squared plus 40 squared plus 66 squared. So 10 squared plus 40 squared plus 66 squared minus, and then that number we already solved for, so just for simplicity, I'm just going to write that number again, which was 2018-66. Okay, so 10 squared plus 40 squared plus 66 squared should be 60,056. Minus 2018.66. Okay, so when you plug that in, you should get 40,337.34. Okay, does anyone have any questions on how we got there? No? Okay. So now we just need to do the total sum of squares. So that should just be where you add the two up together. So it would be 523.55 plus 4,037.34. So you just add the two up and you should get 4,560.89. Okay, does anyone have any questions for that? No? Okay. So now we need to calculate the mean squares between. So the formula for that would be MS between is equal to, so SS between divided by the degrees of freedom between. So this is also where the degrees of freedom between and within come in. So we calculated our SS between to be what? It should be this number, right? Okay. So 523.55. What was our degrees of freedom between? Can anyone tell me?
2.
2. Yes. Okay. So then 523.55 divided by 2 is what?
261.775.
Good. So let's just do 2 decimal points. So 261.78. Yes. Okay. So now we do our MS within. So everything is the same. We just use the within values. Okay. So what was our sum of squares within that we calculated? So it should just be this number right here. 4,037.34. And then what was our degrees of freedom within? Yes, 6. Thank you. Okay, so when we plug that into a calculator, 4,037.34 divided by 6, it should be 672.89. Okay, does anyone have any questions on that before we move on? No? Okay. So the next thing we need to do is calculate F. So to calculate F, you just do F is equal to MS between divided by MS within. Okay, so we said our MS between was 261.78. And what was our MS or our MS within?
The 672.89.
Good, 672.89. So now we just divide those. 261.78 divided by 672.89. So you should get 0.39. Okay, so based off that, we need to make a decision. So I'm going to share that poll. We'll give it about 30 seconds to decide. All right, we'll give it about 15 more seconds. Our F critical was 5.14. Just for anyone that missed that. Okay, I'm gonna end the poll. So the correct answer should be retain the null. Which is a type 2 error. Can anyone tell me why we should retain the null?
Because the number you got is smaller than the F critical.
Yes, perfect. Thank you. Okay, does anyone have any questions on that? No? Okay. So let's write our statistical verification. Why is it type 2? So anytime you retain the null, you have the possibility of a type 2 error. So it's going to be the same every time. So retain goes with type 2 and reject goes with type 1 every time. Okay, so then let's do our statistical verification. So F is equal to, so it should be DF between, comma, DF within is equal to, so that should be our F calculated. And then P is something to 0.05. So let's fill in everything we have. So what was our DF between again?
$523.55.
So you just want the degrees of freedom.
Oh, 2?
2, yes, thank you. 2, and then what about the degrees of freedom within? Okay, so our degrees of freedom within should be 6. 6, and then our calculated was 0.39. Okay, so since we are retaining the null, should our P be less than or greater than 0.05? Okay, it should be greater than. So anytime you retain, P would be greater than. Anytime you reject, P would be less than. Okay, so we're not going to go over the ANOVA summary table. That's just where you fill in all the information that we calculated into one table. So that's the end. I'm going to send the links again for everyone, just in case you need it. So you have, just a reminder, you have until 4 o'clock today to fill out that survey. So I can email you guys the blank worksheet, the worksheet we worked on, and the key. So that's it. I'm going to stop recording.